Hello, everybody. So we are trying to demonstrate today our first experiment in electrostatics. To do this experiment, you will need an electrostatics kit, which is right in front of you here. It basically is a few pieces of different materials of fabric and a few solid rods, and at the end of the line you can see the plastic tube with a couple of orange caps in both ends. This is both like the plastic solid object that you're going to check the charge and nature of, and also this has styrofoam indicators inside, which basically will start moving as soon as you bring a charged object near it. On your left, you can see an electroscope. I don't know how easy it is to see, but you can see that there are like two plates. One is a solid straight plate, and another is a very thin metal foil. You will see that that metal foil basically deflects, or the gap between them will basically increase. It will just fly off almost whenever you bring a charge. Depending on how much charge you are bringing, the deflection will be less or more. I have also enclosed a copy of these static tube kit descriptions in your lab manual, which is uploaded in the Canvas. You can see by, or you can identify by color, which fabric is what. So there is like a purple, red, you can see the far easily, and then you have a yellow, white is this one, not in a very good shape but still will work fine, and then you have also a brown tweed. I guess that's wool. So let's begin. You will see that it's fairly simple of what we are going to do in here, and in order to continue, let me first bring this or at least have this mounted so that you can see a good representation of what we are trying to achieve here. Okay, so this is a good enough view of the electroscope, and I'm going to basically show you how it changes with different materials. So I'm picking up first the metallic rod. So this is the metallic rod. I am going to rub it with the brown tweed, which is basically wool. You will see that I have rubbed it abruptly, vigorously, and then I'm going to bring the metal rod, and you see a little bit of reflection. The second set is I'm going to keep the fabric same, and I'm going to quickly change to plastic. This is the plastic. I am rubbing it with wool, and you can see that the deflection is a lot. Third in line is this. I think it's also plastic, some sort of, but we'll see. You can describe them by their colors. Okay, so just write the black rod with plastic-like structure. It's not actually a plastic, I would say, but you can see that it barely moved the electroscope. It did not move at all, so there is no reflection, and I'm still using the same piece of cloth. Okay, so that's our third object. And now a glass rod. So this is a glass rod. I'm still using the same felt or tweed actually, sorry. A little bit deflection. Not a lot, but it's there. So for all these four objects, we have rubbed the four solid objects with this brown tweed, and you have seen a reflection. Now I'm going to move on to our second piece of cloth, which is yellow, and that's the silk. So this is the silk we are going to use for the next set. And I'm starting with the glass. I am rubbing the glass and then I'm bringing it. You can see now it has a little bit of deflection. Moving to the black rod, keeping the same fabric, silk, almost nothing. Plastic, which is this guy, rubbing again. A lot, right? Almost the maximum. Finally, the metal, and let's see, almost nothing. Don't be fooled by the first deflection that you see. Sometimes it's for discharging. Okay, so now we are done with the yellow piece of cloth. So we'll set it aside. We are done with two of them. Our third one is the white colored cloth, which is nylon. So this is nylon, apparently. And our first will be the metal rod. So I am rubbing it just like that. Probably something. Let's give it another shot. Almost nothing. So it's probably discharging. Okay, moving on. Glass. Also nothing. Almost nothing. Probably nothing. It's interesting that you can bringing it near and it's not showing that much deflection. When you're taking it away, it's giving you some deflection. So it's probably the sign of the charge. Okay, anyway, some deflection. Black rod. Some deflection. You will have to characterize them on the basis of how large a deflection you are seeing. Finally, the plastic rod. Oh wow, a lot, right? So yeah, on the basis of how much deflection you are seeing, you are going to put a comment in the remarks column of the lab manual that you have. Okay, so the next one is red. That's rayon, and we are going to follow the same procedure, starting with the plastic. By now you have probably remembered This is the plastic that you are seeing the reflection for. Second one is glass, the black rod, which probably is, I don't know, it's probably something else. It's not plastic, it's not glass, could be something else, but you can see that it's not moving the electroscope at all, basically meaning that it's not chargeable. It cannot attach or generate electricity, meaning that you can't really move electrons out of it that easily. So the third one in this series is the glass, and see what happens. A slight deflection, I would say, because you're taking it away. Once you touch the electroscope, you will transfer all the charge to the electroscope, because this is basically a metal on top of it. Okay, so on top of it you have a metal object, and once you touch it, you have transferred all the charge to the electroscope itself. Now both of these two filaments will have same charge, so they will repel, and if you are now taking it away, you are doing a little bit of induction, basically. So alright, moving on. The last object in this series is the metal rod. We're still with the red. We're still with rayon. You discharged and nothing else. So it generates a very small amount of electricity, I would say, static electricity, but since this is conductor, a metal rod is a conductor, you are transferring those electrons quite fast to the ground, because our body is a good conductor of electricity. Okay, so it's through the rod, metal rod, through our body, all the charges are going to the ground. And now we have a purple, which is basically cotton, right? So we are going to start with the metal rod, vigorously rub it, just in case we are not missing anything, and we are not. You can see that it's barely moving. So you don't either generate any electricity or any static electricity, or you transfer whatever small amount is generated to the ground quite fast. Second in line is the glass. Nothing happened, and I'm still using the purple. Third is this black mysterious material, which so far did not give us any deflection at all. Oh, look at that. Now you have a little bit of deflection, right? Okay, so it did generate a little bit of electricity with the cotton. So you can see that it's highly selective regarding the rubbing and generating electricity, though. And plastic has always been the best in terms of how much static charge you can generate. So that concludes our listed 5 material over there, but we still have a FAR, which is not listed there, I guess. We still have this guy. Okay, so I'm going to quickly do that, and you're going to see a lot of deflection for plastic, large deflection. So if you have to ever characterize a large how these deflections are in your remarks tab, you're going to say small deflection, no deflection, medium deflection, or large deflection. Next one is the black rod. I'm still using the piece of FAR we have. Nothing. This guy never really gave us a lot of deflection, did it? Now I have a glass. Nothing. Finally, the metal. Again, a little bit of discharging, but you don't see a lot. So this concludes all the 1, 2, 3, 4, 5, actually 6 materials, 6 fabric materials, and 1, 2, 3, 4 solid objects to be mixed and matched, and you have seen results for each of them in the electroscope, which is this guy. Now the final part of your activity is basically to list down everything that you have seen so far. So take a look. This is the only page that you will need to fill out. You have material as cotton, rayon, nylon, silk, wool, and FAR, right? The very left column. For each of these guys, you are going to use glass rod, plastic rod, metal rod, and I forgot to write down, but you have a fourth one, right? So write black mysterious rod if you want, and then you have rayon and all the 4 objects, nylon, all the 4 objects, silk. You get the idea. You don't have to fill out this styrofoam indicator tab because it's very difficult to see it without actually doing it by itself, and it's not very easy. So we are going to skip this. I'm going to show you at least one instance, but that's for later. You have this tab to be filled out, electroscope, right? In this one, you are going to say either if you saw deflection, so yes or no, and then here you're going to fill out with how much deflection you have seen, or if you have any other comments regarding how what might have happened. Okay, so this is the only page that you need to fill out. Again, you have this included in the instructions. You still have this static tube kit information that you want to read will be uploaded there as well. Once you're done, each of you will basically submit the assignment, the lab assignment in Canvas, where I will create an assignment where all you have to do is basically go there and submit it as a file, and then I'm going to grade straight from there. Now, last thing is basically if you want to see how the other indicator works, the styrofoam. So let's pick out these guys, and you can see they have styrofoam granules inside. They basically are movable, but it's quite misleading sometimes because this is plastic, and we have already seen that the plastic surface is very chargeable, very easily chargeable. So generally speaking, if you rub any of this material, you are going to see these guys are moving away from the surface, right? So you can see that you have now created a void in that region. It's basically because if you are rubbing it with a material, you are moving these guys. Okay, so it works like this, and you can see that it has a lot of charge. Electroscope does a much better job in indicating what's there. In the second part of electrostatics, you are going to work with a simulation for Coulomb's law. You will upload information regarding that separately. But if you have time, take a look at this video. Ask me questions if you have any confusion or doubts or just general comment. And good luck. Goodbye for now.